Alright, this is Mrs. Stanton and I am working problems 1, 2, and 3 from Special Parallelogram Quiz 2. Take a look at your quiz and make sure LK equals 12 on number 1. If LK equals 12, then you're watching the correct video. Alright, so we would start each problem that we do by drawing a picture if one's not drawn. So it says it's quadrilateral JKLM and it says it's a parallelogram. So let's sketch ourselves just a quick parallelogram, nothing fancy. Now it's really important, sorry that was very bad, to label your parallelogram correctly. So there's no jumping across the parallelogram when you're naming. Make sure you always name in a circular motion. It doesn't matter where your circle starts, J, K, L, M, but you need to go in a circle. You need to end where you started. If I started at J, I need to end at M, and the next one should be J again, like going in a circle. Alrighty, let's label our sides. ML, 2y minus x. LK is 12. KJ is 2x minus y. And JM is 2x minus y. Now, we know that opposite sides are congruent, right? That's one of our properties of parallelogram. But as I'm writing this, I noticed something. Did you notice that JK and JM are the same thing? 2x minus y and 2x minus y. So it's just kind of good to be aware of what's going on in your problem. That's not really going to mean a whole lot to me right now. But I noticed that if opposite sides are congruent and those two consecutive sides are congruent, then I automatically have a rhombus. So this is a rhombus. All sides are 12, by the way. All the sides are 12. But we're not looking for the sides. We're looking for x and y. So let's see what we can come up with. So I'm going to set opposite sides equal. So 2x minus y equals 2y minus x. And then I'm going to, in a different color, I'm going to set my other sides equal. 2x minus y equals 12. All right. On this one, let's get all of our x's on one side and all of our numbers, well, all of our y's on the other side, rather. So I'm going to add x to both sides. Those will cancel. And I've got a total of 3x. If it's okay, at the same time, I'm going to add y to both sides. Those will cancel. I've got 2 plus 1, 3y. Wait a minute. 3x equals 3y. The 3's cancel, and wow, look at that. X equals y. X is y. They're the same. So once I find x, I've automatically found y. Okay, we're going to do a strategy called substitution. We're going to take what we just found in that equation and we're going to substitute it into the other equation. So x is y. So instead of y, I'm going to write x. 2x minus x equals 12. It's called substitution. Y and x are the same. They're interchangeable, so I'm substituting one for the other. 2x minus x. Well, that's just x equals 12. Wow. So the sides are 12 and x is 12. We already found out that x is y. They're the same. So if x is 12, y is 12. So that system of equations actually wasn't as bad as you thought. Next problem, number 2, rhombus Andy. And the cool thing is that we already drew a picture for you with the diagonals and everything. Let's see what angles we are zeroing in on. ANY is this angle, and DYN is this angle. Well, whether it's a rhombus or not, those are alternate interior angles. So whether that's a rhombus or just a plain old parallelogram, we would set these equal either way. So we're going to set them equal because they're alternate interior angles. X squared minus 2x equals x plus 54. I know that this is a quadratic because I've got an x squared and I've got an x, and none of that's going to cancel. So I have no choice but to bring everything over to one side of the equation. X squared minus 3x minus 54 equals 0. Now I need to brainstorm things that multiply to get 54. So you go to your calculator, 54 divided by 2. Okay, well that's nice, 2 and 27, but I can't make a 3. I can't make a 3 out of a 2 and a 27. So you can divide it by 4, you can start dividing it by whatever you want. You can get all the way to 6. 54 divided by 6 is 9. So I know 9 and 6 are my lucky winners because I can make a 3 out of a 9 and a 6. So I put my parentheses down, equals 0, x, x. So I chose 9 and 6. It doesn't matter where you put them. Now we have to decide if they're positive or negative. That 3 in the middle, that's a negative 3. So I want my bigger number to be negative so it can kind of overpower my smaller number. So I want my bigger number to be negative, and then there's my plus 6. All right? We need to actually solve for x. That's not what x equals. We need to actually solve. What number forces that one to equal 0? Well, 9 does. What forces that one to equal 0? Well, negative 6 does. Now, when you have a factoring problem and you have two answers, you need to decide, do I keep them both or do I throw one out? Because every problem is different. How do you decide? You plug it in here and you plug it in here, and you make sure both get you a positive angle. If I plug 9 in, I'm totally safe. If I plug negative 6 in, I'm actually totally safe this time too. Negative 6 plus 54, that's great, that's wonderful. So let's look and see what angles we're actually trying to find. So take a look at your picture. We're trying to find YAD, we're trying to find that green angle, and we're trying to find YDN, the blue angle, the green and the blue. So the blue and the green. Let's try to find our red angle first, because I have a feeling our red angle is going to affect our other ones. So let's plug either one in first. It doesn't matter. I'll plug 9 in. I'm going to plug it into the one that's easier to plug in. 9 plus 54. I think that's easier than squaring it and subtracting things. Okay, so 9. Okay, 9 plus 54, sorry. So we've got 63. So those red angles are 63. Now, I know something about a rhombus. I know the diagonals bisect the angles because you've memorized that. So I know that in a rhombus, if my angle is 63, then this angle is also 63. I also know in a rhombus that my diagonals are perpendicular. So if I were to redraw this triangle, I'd have 90, I'd have 63, and I would have green angle. So you know in a right triangle, when you know one angle, one acute angle, the other one is just 90 minus that angle. So you would do 90 minus 63, and you get 27. So my green angle is 27. But wait, I had two answers for x, so I have to plug the other one in. If I plug negative 6 in, negative 6 plus 54, I get 48. So I've got that same triangle, but this time this is 48, and I'm still looking for that one. So then I would do 90 minus 48, and I would come up with 42. Now, in a rhombus, the diagonals bisect the angles, and opposite angles are congruent. So once I know the green angle, I can get the blue angle by just doubling the green angle, because the green angle is half of that angle because the angle is bisected, and then opposite angles are congruent. So all I'm going to do is take my answers. I'm going to take 27, I'm going to double it. 27 doubled 54. I'm going to take 42 and I'm going to double it. 42 doubled 84. So we've now found the green and the blue angles. Last problem, problem 3. Once again, there's no picture drawn, so we better draw ourselves a picture. We've got parallelogram A, B, C, D. Make sure you're naming it in a circular fashion. AB is 4x plus y. BC is y plus 6. CD is 3x plus 7, and DA is 2x plus y. We know in a parallelogram that opposite sides are congruent. Surprise, surprise. So let's go ahead and set our opposite sides equal. 4x plus y equals 3x plus 7, and 2x plus y equals y plus 6. Now this is starting to look like a pretty yucky system of equations. But you've got to be on the lookout for shortcuts. You've got to notice what's going on in your equations. Look at that second equation. Are you looking at it? Do you see a y on the left and a y on the right? Yeah. So if I were to subtract y from both sides, guess what? The y's would cancel. A y on the left and a y on the right means they cancel. That is awesome news, guys. Those y's cancel. This equation really just says 2x equals 6. This equation really just says x is 3. And this problem turned out easier than we thought. X is 3. Now we just plug it in. Let's plug it into the one we haven't touched yet. Let's plug it in here. Instead of x, I'm going to put 3. 4 times 3, 12. Plus y equals 3 times 3, 9 plus 7. So 12 plus y equals 16. Y equals 16 minus 12. So y equals 4. So we got 3 and 4. Okay, those are the only problems I'm working from this quiz. You can ask a friend or ask your teacher if you need the other problems worked. Thank you for watching.